All right. So at our church, we have a security team that we are interested in a way to at least alert one another on the team at a distance. We don't want to be wearing the earwigs, looking like FBI agents. We want to keep an open, friendly environment. We wound up looking at a couple different off-the-shelf options, but they're all kind of like the one or multiple alert buttons, but a single station, or a single recipient will receive the alert versus multiple buttons, or multiple people will receive the alert with one button, which really didn't do the trick for us. We want to be able to have someone at any one location alert the others. So I started looking into what are the options I can make for myself. And the first talk is going to be just covering the Arduino component and the electronics to it. I'm going to possibly do two other talks, one of them about 3D modeling and printing, or 3D printing with that. And then I might do another one on how to get your own PCB design, or to design it yourself and then get it printed and actually use your own PCB. So let me kind of demo the system. So that's why I switched to this camera. Hopefully no one gets motion sick. Here's basically the guts of the thing. Let me see if I can center it there. And we've got the Arduino component right here. I've got a display component, which is, on this one, is a 128 by 68 or 64 OLED. Here's the 3D, or sorry, not the 3D. This is the PCB I designed, and then in the center there's a button. And then I've got an LED over here that is set up to be, or inside of the actual boxes, that's just a motor that will allow people to feel the vibration. So the idea is that one of these components, someone would hit a button that will alert all the other devices. So next to it here, let's see, yep. So here is the other devices, and then they will start vibrating. They'll hit their button. That will notify the person who originally hit the alarm that the someone is responding and going to come and help them. They can then hit their button. That'll clear their alert. So let me just give a quick demo. So this guy, sorry, there is I haven't updated the code on these here, but you can see alert 5. So that's, this device is 5, address 5.
How to change, how to turn off the video.
Well, I tried. It just.
So 1 and 2 both responded, and then after 30 seconds, the whole system clears itself. So I'm going to kind of cover the components that I use for this, and then I will show a little bit of the code, how to get it working. So over there. So I'm going to share my screen. Let's see. All right. So my notes are not showing up. Oh, there we go. All right. So some of the things that I needed to pull this off was an Arduino, and I was looking for one that had some sort of radio that I'd be able to communicate with the other devices. I looked around at a couple different options. I wound up with the RFM69 packet radio. It's a decent distance radio, runs on the 915 megahertz band, and that allows me to easily cover the entire distance or area around my church. And it goes through all the walls, especially with the quarter antenna on it. One of the other advantages of the Adafruit Feather is that it has a 3.3 volt chip that runs it, and also has a LiPo battery charger integrated into it also, which, because these devices need to be carried around by people, I wanted to be able to have it on a battery. This put it all on a single board for me. That allows me to really not have to invest a lot of effort. I don't have to do a ton of wiring and have another circuit inside of the entire system. The RFM69 radio, or packet radio, that basically has a library from Adafruit that I'm using that makes it very easy to just read and write packets. You can set up a encryption key that will only communicate with the devices that know that encryption key. So if someone else is using an RFM69 radio, the odds of them actually having the same key as what I'm using is pretty unlikely. Therefore, I don't have to deal with interference also. The display, ones that are actually in the boxes that you saw that were printed, those are the first generation ones that I did before I started using the OLED display. So I would have stayed with those, except for the second box that I had ordered that had 3 of them in it. None of them worked, and Amazon doesn't carry them anymore, which I guess maybe because they were having quality issues. So I'll cover a little bit of the display drawing libraries that both of those use. Let's see. The circuit also integrates that 6mm button and little vibratory motors. And to drive that, I needed to have a transistor in the circuit to just because none of the power coming off of the Arduino actually was able to drive the motor itself. So let's actually look at some of the code. So if we go over to the Arduino app, I'm going to pop over and just see if there are any active questions so I don't steamroll over everyone, which I don't know how to do. Let's see. There we go. If you do have questions, I guess toss them in room 20 chat, and I will look for them, but I'm not seeing any. So I guess I'll keep going. So each of the devices has a unique ID, and the device that you were seeing that was on the breadboard, that one is just right now set up as device 5. I'm just using an individual bit to for the address or ID for it. In the US, the open frequency that we can use is 915. I believe in Europe and most of the rest of the world, it's 433 is the megahertz frequency that you're using. Or not megahertz, I guess hertz. So I guess here's the encryption key that I'm using, which I guess each time I commit it to GitHub, I wind up having to clear that out to all zeros. But I suppose if you all see it, not a big deal. You'll see I have a bunch of defines around graphics, and that's to support both of the graphics displays. This is just a bit there. Debugging will actually debug to the serial output, so I can kind of show you what that looks like if I open up the serial monitor. So spitting out the battery voltage is actually not useful since my breadboard doesn't have a battery hooked up to it. But if I were to hit like one of the buttons, you can see a bunch of the stuff goes through there. So my event time is 30 seconds. The duration of the vibration is 5 seconds. So a lot of this isn't terribly interesting. I've developed my own little message packet, which is fairly simple for my purposes, which is just a structure that does the version in it, then the device ID and the action that it's doing. There's 3 actions. It can alert, or respond, or acknowledge that it received it. Then I've got my UX state. This is has a button been pressed, and at what time was the vibration started at, so it knows when to clear it out. Then I've got the actual application state, which is all the information pertinent to that. So let's kind of go in here. So if I'm using the LED matrix, just the 8x8 LED matrix, it's really simple. I do a quick Adafruit 8x8 matrix, and that handles all of the SPI communication for me. It just gives me a nice interface to work with. Similar with the OLED display, it's the same thing as far as it handles all the communication behind the scene for me, so I don't actually have to do anything interesting there. So one of the things, or if you're not familiar with Arduino coding, you've basically got 2 entry points. You've got a setup, which is where you're going to do all your single setup type things that you're going to do for all of the hardware. And then there's a second function, which is loop. And this loop, basically, the application is going to call loop, and then you get an entry point, you return from that, and it's going to call loop again. One other things that you can implement in Arduino but aren't really necessary, but I'm using is a interrupt subroutine, which I'll show where I set that up. And that basically, when I pull one of the pins on the Arduino, either down or up, I'm not sure which, until I find that, it will basically cause control to jump from wherever it is to that interrupt subroutine. So let's look at the setup function. Basically, we're going to set up serial. I really probably only have to do this when I'm actually going to be doing with debugging on. So that's probably a change I can make here. Right here, I'm doing a pin write to the RFM radio reset pin. I'm setting it to output, and then I'm going to set it low. Then basically you write high, low, and that tells the radio to reset. So you make sure your radio is ready for the rest of the commands it's going to receive. The init is going to wind up initializing the radio for all the communication purposes. We set the frequency on that. We set the power. There's 2 power levels that you can do on the radio that allow you to, one will allow you to broadcast louder. It uses more battery and such, but there's an encryption key that you want to set on that radio, and then promiscuous. I think I could actually switch that to false at this point, but that would allow you to pick up additional things that aren't addressed to you. When we look at the write function, no, I do need it in promiscuous because you can say I'm only interested in writing to a particular device address, and I'm not using that device address part. Graphics, again, this is if I'm using the 8x8, the begin, and that's an address on for SPI, I think, and it allows you to, I think it sets the SPI address. So therefore, when you do writes to the serial, it'll get to the right thing. The graphics for the OLED is a little bit more complex to set up, as you can see, but that's not, I'm not going to cover all of that since I'm not exactly sure. That's more boilerplate than anything else. One thing about the OLED display, though, is that you need to call a clear display and then call display to show a blank screen before you wind up having, or if you don't call clear display, it will remain in the state that it was prior to. So you'll see that clear display before I write anything to the screen. A couple other pins that needed to be set up is the battery pin. This is one of the pins on the Arduino that tells you what is the, or if a battery was hooked up, what is the voltage of that battery. So you could make decisions on what to do. Whether like if you're at low battery, do I want to like attempt to shut down completely or turn the radio off or turn the display off or something like that. Let's see, the button pin, that's a input pin. So here's where I'm attaching an interrupt to that. So it is, so when the pin goes high, so when I press the button, that's going to send a voltage back to the pin. When it starts, when the voltage goes up, that's when the interrupt handler is going to get called. So that means when I push the button down, it's going to. So if, which is closer to what a normal button does, but for computers often, when you lift off of a mouse button is when the event handler happens. Or you'll see that with phones, like phone applications. That way someone can push the button accidentally and then slide their finger off. This one doesn't have that feature. Then I've got a motor pin, which is going to be hooked up to the transistor, which is going to wind up routing full voltage out to that. So a loop, as I had mentioned before, the loop is a fairly simple part of the application. I'm going to spit out debugging to the battery voltage, which that's a feature I haven't fully developed. But my button pressed, this is basically saying, hey, if the button's been pressed, we're going to process that button press. And then we're going to process any messages that have come over the radio. And if we have reached the end of an event, we're going to clear out our state for the event. And then we're going to check, should we stop vibration? If we should, then we'll stop that. And then we're going to delay for a second and go back through the loop. So there is a delay in my system here. I could switch things around to be fully event driven, which would probably give me slightly better battery life, but I only need these things to run for probably about 3 to 4 hours, and the size of the battery that I have in there, they'll last actually about 24 hours. So I'm a little sloppy in my programming here. So that's just something to be aware of, especially when you're doing something that's all battery oriented. You can change how you do things a little bit in Arduino or in the Arduino environment to make things better for battery life. Let's see, I guess at this point, I'm not going to go through how all of the state of the application works. I know that certain things, like I would like to split this up so it's multiple files and such, but I'm not an Arduino genius by any means, but just kind of what I've learned as I've gone along. So I guess I'll open up for questions. Let's see, I'm not seeing any questions in the Room 120 channel right now. So folks have questions, go ahead and unmute yourself and I'll try to answer them.
Did I see you have like a battery charger for those?
Yes, the Arduino does have, or the Arduino has a battery charger. Let me kind of, just a second. I know I've got some spare batteries somewhere. Ah, there we go. All right, so I can't see my own screen when I'm doing this or what's being displayed. So this is one of the LiPo batteries that I picked up. They're a 72 milliamp hour LiPo battery. They've got kind of these little connectors, if you've seen them before. I think they're called like 3.3 volt or 3.7 volt connectors. And then the Arduino itself, let's see. Let's see, sorry. This is, you can kind of see by that red LED, there is a connector. So I will go ahead and connect that real quick. So when it's yellow like that, or that one LED is yellow, that is when it's charging. So then it'll be a different color if it's not charging or not connected. So do you have any other questions on that?
You have a dock next to that you were charging them on? Or is that just a holder?
Oh, so over here, let's see. Come on, where are we? What am I looking at? Oh, I'm upside down, sorry. All right, so yeah, this is a dock that I picked up off of Amazon because ideally I want 4 of them available for the security team at church. So that is the long-term plan. I've got some new cases being printed out though right now. So
did I understand correctly that the Arduino itself has the charging circuit in it?
yes, it does. So let me pull up one of my spares and I can hopefully show that a little bit better here. So the Arduino comes with a couple headers. Let's see. There we go. Is that a little bit better for seeing? So the charging circuit's where my thumb is. Then these Adafruit M0 feathers, they all come with the charging circuit, and then they have a radio down at this end here that they've got a bunch of different radios. I think they've got the Texas Instruments BLE chipset, and I've seen a couple other chipsets. So if you're interested, I think there's a Wi-Fi chipset one too. So they have a bunch of different options there. And at least I found that where it's all on a single package, invaluable. I mean, I think it's $20 $25 per Arduino there. So they're a little more pricey, but if you're gonna, for the ease that it gives you, it's a lot better than having to go out and buy your own radio separately. And,
Now,
especially with RFM. Go ahead.
When you do the radios, do you find you have problems in the building? I mean, do you have to use like a repeater somewhere or relays or?
Not with this RFM69. That I've been able to, I've easily been able to do without an antenna, probably about 250 feet. I think with a quarter antenna, like what I've put on these, I think you can get up to like a quarter mile or something like that at your highest broadcast.
Awesome.
Yeah, so they're really quite impressive for the little package that they are.
So I've played around with Raspberry Pis a bit. So this is like the baby brother of Raspberry Pi because I see the circuitry is a lot smaller. Is there something that you can, for somebody who's starting out on Arduino, Adafruit, is there a place where we can start?
So the first Arduino I picked up was, it came in kind of a kit full of, in fact, I think I actually won it. I don't think it was at Barcamp. I think it was at like the .NET days or something. But it was a kit that had like a bunch of different projects in it and such. And that's kind of what I'd recommend starting with. And just something that has multiple projects. It's going to have a bunch, or it has a little breadboard in it, has a bunch of other stuff. But once you've done that and gone through a few of those projects, they're really quite easy and very approachable. And then you realize, oh, hey, I can do a whole lot more. Now, you don't have a full OS on it. It's not like a multi-processing environment like a Raspberry Pi can be. So you're not installing like a distribution of Linux on it or something like that. It's just the environment itself. So
cool. No, this is super awesome. Good stuff.
All right, I'm glad you liked it. Anyone else have any questions? We've got 2 minutes to switch over to the next session here, it looks like, which I think we'll all be going and playing Pandemic, it looks like. No, nope.
This room, so you're more than welcome to keep going, but yeah, the other sessions will be running concurrently. Yep.
So I might, by morning, try to put together the 3D printing or the 3D modeling for the cases talk. This was before I even planned on it. I was planning on doing this tomorrow morning. So hopefully everyone was well enough entertained. I'll see you around at the other sessions, all right?